The last part of this lesson is learning how to solve a system with matrices, and this will make your life a lot easier because our calculator will be doing the work. So a matrix is a rectangular array of numbers. It's a way to organize our information into different categories with rows and columns. So when we have a row and a column, it's going to create this matrix. That matrix has a dimension. So its dimensions are m rows by n columns. This is 2 rows by 3 columns, so it's a 2 by 3 matrix. So it gave you a few examples. This is, again, 2 rows, 3 columns, so it's a 2 by 3. But this one is only 1 row with 4 different columns, so it's 1 by 4. We can write a system of equations as a matrix as long as they are all linear equations, so it's all degree 1. So if I take this, we're going to put all of the variables on the left and the equal stuff, the constants, on the right to create what's called an augmented matrix. We write only the coefficients and the constants, but they have to be in order. So if I look at my x's, they're all in a row. The coefficients for your x's are 3, +1, and -1. Our y's have a coefficient of -2, 3, and 0. And z's are 1, -1, and 4. These things are all matching up with this augmented matrix, where our x's, our y's, our z's, and our equal to's are the last. Our system calculator, our system solver in our calculator is going to do the work for us. So if you have a system solver, it is above this tangent button. You hit second system solve, and it has either a 2 by 2 or a 3 by 3 system. We just need to decide what type we have. So in this first example, we have 3 variables, which tells us we have a 3 by 3. We want to take this and write it as a matrix with the x's, y's, and z's on the left and our equals on the right. So the coefficients for the first one, there's 1x, a -1y, a +3z, and it's equal to 3. So that's the first row of our matrix. Then I have 4 x's, a -8y, a 32z, and a 24. 2x minus 3y plus 11 makes that 2, -3, +11 equal to 4. This would be our augmented matrix that we're going to put in our system solver. So I go down here to 3 by 3, and we just put in the numbers that we needed to. So I still got old ones in here, but I'm just going to make sure that dang it, there it goes. Put in the number. So 1 equals, that's got to change to a 1. -1 equals 3. And then the last column was the constant row, so it should equal to 3. We had 4, -8, 32, 24. 2, -3, 11, and 4. Just make sure, double check it before you hit solve, that you've typed all the numbers in correctly with the correct signs. Sometimes we get to typing too fast in our calculator and it solves it incorrectly. So I solve, and this says no solution. We do the second one. Our system would be 1, 4, -2, -3. 2, -1, 5, 12, -3, +1, -4, -3. Now we type that into our calculator again. We have 1, 4, -2, -3, 2, -1, 5, and 12, -3, 1, -4, -3. Solve it out. Now we have x equals -13 thirds, and you scroll down to get your y. So y is 8/3, and z is 14/3. So I can write that as our point, like we did all the others. This really makes it a lot faster to solve a system. Our last one, I'm still looking to see that all the x's, y's, and z's are in a row, but I see automatically that this second row is shorter, which means there's something missing. There's a 0y here. So 1, 2, -1, and 9 are coming from the first row, but 2x, 0y, and -1z, -2. If I don't put the 0 there, it doesn't have a placeholder for me. So we have to have the 0, 5y, and 2z, 22. Let me plug this one into the calculator again. So let's see, we get 1, 2, -1, 9, 2, 0, -1, -2, 3, 5, 2, 22. Solve it out, and x is -1, y is 5, and z is 0. So -1, 5, 0. We do want to look at word problems with these as well. So you could solve these algebraically, or you can use the calculator for our system solver. But setting them up is the most important. So we have Billy's Restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. So all of this has got to come into some type of equation. I've got x, y, and z. So x I can let be carnations. R we could do roses, or y we could do roses, and z we can do daisies. I could also just let this be C, R, and D either way. One thing I know is that I have 200 flowers. So all of those put together makes 200. I can do x plus y plus z is 200. Then I have $1.50 for each carnation, $5.75 for each rose, and $2.60 for each daisy. So $1.50x plus $5.75 for each y plus $2.60 for each z equals the total amount of money that we have, which is $589.50. The last equation is a little bit harder to do, but we know that there are 20 fewer roses than daisies. So the roses would be daisies minus 20. Or in this case, we could say y equals z minus 20. If we want to solve this with a system solver, we need to get all the x's and y's on one side. So I would just move that z over, and I waited to put this here so I could say y minus z equals -20. And now this is something that I can set up with a matrix. So that matrix would be, I'm gonna have to write small, but 1, 1, 1, and then 200. $1.50, $5.75, and $2.60, and equals $589.50. The last one has 0 x's, 1 y, and -1 z, equals negative 20. So we're going to type that into our matrix to solve this out. So 1, 1, 1 equals 200. $1.50, 575, and 260 is 589.50. 0, 1, negative 1, negative 20. Solve it out. Now we have all of the solutions. So x, let's do this in x equals 80. Scroll down, y equals 50. And z equals 70. We do want to interpret what that means. So that means that there were 80 carnations, 50 roses, and 70 daisies. If we go back through the equations, we know that we had 200 total, so 80 plus 50 plus 70 does equal 200. We also said that we had mostly carnations, that's true, and there are 20 fewer roses than daisies. All right, example 2 says the Arcadium Arcade in Lynchburg, Tennessee uses 3 different colored tokens for the game machines. For $20, you can purchase any of the following mixtures of tokens. So we have all these different mixtures that you can look through. And then what is the monetary value of each token? This is actually set up a lot easier for us because 14 gold, 14G, plus 20 silver, plus 24 bronze, you get for $20. We also have 20 gold, 15 silver, 19 bronze, so 20 gold plus 15 silver plus 19 bronze is still $20. And then 30 gold plus 5 silver and 13 bronze is $20. So that one's set up pretty nicely for us to do a matrix. I would just turn that matrix into 14, 20, 24, 20, 20, 15, 19, 20, and then 30, 5, 13, 20. So system solver 3 by 3, 14, 20, 24, 20, 20, 15, 19, 20, 30, 5, 13, 20. Just double check what we have and solve. So then x equals 1/2, y equals 7/20, and z equals 1/4. So what does that mean? All right, a fourth or a half and 7, that's all talking about that much of $1. All right, so x equals 50 cents. Y equals 7/20 of $1. So 7/20 of $1, which is 100, is 35 cents. And then 1/4 of $1 is 25 cents. So there's our values. 3, we have last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets. Their proceeds totaled $64,600. Tickets can be bought in one of 3 ways. So matinee, that's $5, student admission $6, and regular admissions are $8.50. How many of each type is sold if twice as many student tickets were sold as matinee? So let's set up our equations That first one says that there are 8,500 movie tickets. So all of them together, matinee plus student plus regular R is 8,500. Proceeds totaled 64,600, so $5 per matinee plus $6 per student plus $8.50 per regular is 64,600. There's all the money equations, but the last equation is coming from this last sentence. So if twice as many student tickets were sold as matinee, so student tickets is 2 times the matinee. There are twice as many. So I can put in, let's put that back over here, S, and if I subtract 2m, that would say negative 2m equals 0. Now we can make a matrix out of this. So 1, 1, 1, 8,500, 5, 6, 850, 64,600, negative 2, 1, 0, 0. And we work it out with our system solver. So system solve and 3 by 3. 1, 1, 1, 8,500, 5, 6, 850, 64,600, negative 2, 1, 0, 0. Solve it out. So x is that first value. So x represents, in our case, m. So matinee would be 900. S was the second one, so S is 1,800. And Y, or Z, I mean, is R. Our regular emissions was 5,800. So I just realized we didn't do that in the last example, so you want to fix that in your notes. At least this was our gold, silver, and our bronze. Okay. And then the very last one. Mabry invests $50,000 into a money market account at 3 different banks. Bank A pays 3% interest per year. Bank B pays 2.6% interest. And Bank C pays 4%. She decides to invest twice as much in Bank A as Bank C. After 1 year, she's earned $1,533.28 interest. So how much did she invest in each bank? This one's a little bit trickier to set up, but let's say Bank A, this is the amount invested in Bank A. And B is the amount of money invested in Bank B. C is the amount of money invested in Bank C. I put that there because when we think about this $50,000, that is all of this amount invested together. So A plus B plus C is equal to this 50,000. But the interest part goes together. So 3% in Bank A. So whatever she was investing, the amount that she invested is being multiplied by 3%. The amount that she invested in B is being multiplied by 0.026. And the amount C is being multiplied by 0.04. That gave us a total interest of $1,533.28. The last thing is she decided to invest twice as much in bank A as she did in C. So A is 2 times C. If we work that out, I can write that as A negative 2C equals 0. Now I can make a matrix out of this. So I've got 1, 1, 1, and 50,000. 0.03, 0.026, 0.04, and 1533.28. 1, 0, negative 2, 0. And we type that into our system. 1111, 50,000. 0.03, 0.026, 0.04, 1533.28, and 1, 0, negative 2, 0. Solve it out. Gives us how much she invested in each one. So then bank A, we invested 21,207.27. Bank B, 18,189.09. And bank C, 10,603.64.